right, so I want to go over the questions on the pretest, and I'll go through those and see if you understood how to do them. So the very first question, let me make this a little bigger. There we go. So the very first question says, determine whether the polygons are convex or concave. So if you remember from the notes, convex is if there's nothing that kind of goes into the inside of the polygon, and concave does. So again, I think of it as caving in. That's how I would think of it, caving in. So you can see here, this side kind of looks like it caved in. So this one's concave, but this one doesn't have any of those. So this one here would be convex. All right, it says use the figure to the right for numbers 2 through 5. So it says find the sum of the interior angles of this polygon. So first of all, if you remember, the sum for the formula for the interior angles is n minus 2 times 180, where n is the number of sides. So all we really need to know is count the number of sides. So I've got 1, 2, 3, 4, 5, 6 sides. So this would be 6 minus 2 times 180, which is 4 times 180, which is 720, right? 4 times 180, 720. So that would be the answer to number 2. And then here it says find the measure of angle D. Well, I know all the angles have to add up to 720. I know that each one of these angles are congruent because this is a regular polygon. And there are 1, 2, 3, 4, 5, 6 angles, and they're all the same. So I have 6 angles whose measure I don't know, but they have to add up to 720. So if I take 6 angles and I multiply them together, I'll get that 720. Well, if I just want to know what one angle is, I can divide both sides by 6, and I'll get 120 degrees, right? You just take the 720 and divide it by 6, you'll get 120 degrees. So the answer to D is the measure of angle D is 120. They're all 120. This would be 120, this would be 120, and so on and so forth going around. Find the sum of the measure of the exterior angles of polygon. Well, I like this question because it says find the sum of the measures. Well, if I remember from my notes, all of the exterior angles, and again, remember an exterior angle would look like, well, I guess I can draw it on here, would look like this. If I extended each one of these like I did here, this would be an exterior angle, right? So I'm going to have 6 exterior angles, right? 1, 2, 3, 4, 5, 6 exterior angles. But the sum of those exterior angles always adds up to 360. It doesn't matter what the polygon is, it's always going to add up to 360. So the answer to number 4 would be 360 degrees. But then again, now it says find the measure of angle 1. So just this one exterior angle. So just like before, I have 6 exterior angles. If I have 6 angles, I'll have 6 exterior angles. So if I know that I have 6 angles and they're all going to measure the same thing, and their total is 360 degrees, again, if I divide by 6, I know that the measure of angle 1 is going to be 60 degrees. And then it says, determine the area of a square with side lengths of 3 centimeters. So we have a square, which is a regular polygon. And the side is 3 centimeters. Well, because it's a square, all the sides will be 3 centimeters. And if you remember, your formula for area is the side squared. So the area is just going to be 3 squared. So the area is going to be 9. They gave me units, so it's going to be 9 centimeters squared. And number 7 says, determine the length of a rectangle. Now here's my rectangle. And it has a base of 5 inches and a height of 12 inches. And once again, it would not have made any difference if you would call that the base and that the height, or if you drew your triangle going the other way, because you're going to be multiplying them together anyways. So if you remember, the area is base times height, which would be 5 times 12, which would be 60 inches squared. So that would be your answer to number 7. And then number 8 says, find the area of a triangle. Now here's a triangle, any old triangle, that has a base of 6 feet. So this would be my base of 6 feet, and a height, this would be my height, of 4 feet. This is feet. Now, you could have drawn this triangle as a right triangle, right? It doesn't really matter. This would have a base of 6 feet and a height of 4 feet, right? It doesn't really matter what the triangle looks like. Their areas will be the same. So here, if you remember, your formula is 1/2 base times height, or if you prefer, you can say base times height divided by 2. It's the same thing. So my area, my base is 6, my height is 4. If I divide that by 2, this will be 24 divided by 2. So this will be 12 feet squared. And number 9 says, find the height of the triangle. So here's again my triangle. It says find the height. So this is what they want to know. This is my variable h. If the area is 24 meters squared and the base is 8 meters. All right, so once again, always go to your formula. Area is base times height divided by 2. Let's plug in what we know. I know the area is 24. So that's 24 equals my base is 8 times my height, which I don't know, so I'm going to call that h, divided by 2. I want to get rid of my fraction, so I'm going to multiply by 2 to get rid of my fraction. So I'm going to have 48 equals 8 times h. Now to get h alone, I'm going to divide by 8, sorry. 48 divided by 8, again, if you're not sure, grab your calculator. There's no shame in that, right? 6. So your height equals 6 feet. Meters, sorry. 6 meters. And number 10 says, determine the area of the following polygon. And they drew a parallelogram. Parallelogram looks like this, where it gives you a height here of 3, and it gives you a base here of 12. Again, if you remember the formula for the area of a parallelogram, the area is base times height. This one's pretty straightforward. They give you both the base and the height. This would be 12 times 3. So this will be 36. And the units they gave you were feet, so 36 feet squared. And number 11 says find the area of the trapezoid. And they give you here, this height here is 5 centimeters. And this is 10 centimeters. And this is 8 centimeters. So once again, go to your area formula. Area is h times b1 plus b2 divided by 2. Let's plug in what we know. I don't know the area, so that'll stay my variable. My height is 5. Base 1 and base 2. Again, it doesn't matter which one I call 1 and 2 because I'm going to be adding them together anyways. So I'll call this one 1 and I'll call this one 2. I'm going to divide that by 2. And so I have all the numbers. All I have to do is go ahead and simplify this. This will be 5 times 18 over 2. You can just grab your handy dandy little calculator and see you can see it. Here we go. 5 times 18 divided by 2 will give you 45. And remember, your units are centimeters squared. Area always has square units. And number 12 says find the area and circumference of the circle. And it says to use 3.14 for pi. So it gives you the circle, and it gives you this here is 10. So they give you the diameter is 10 centimeters. But if you remember, your formulas are using the radius. So the radius is only this piece. right? Or the other side, it doesn't matter. But if this is 10, then your radius would be 5 centimeters. So your radius is always half of your diameter. So if you want to find the area first, the formula is pi r squared. Plug in what you know. Pi, the radius is 5 squared. But they said use 3.14 for pi, so I'm going to plug 3.14. 5 squared is 25. So all I have to do is multiply those two together. Let's see if you can see both of these. Here we go. 3.14 times 25. 78.5 is your area. And again, it's area, so it's going to be square units, centimeters squared. And then it also said, let's find the circumference. So let's do that. The circumference is 2 pi r. Let's plug in what we know. I don't know the circumference, so that's going to stay a variable. 2 pi, and remember the radius was 5. So I know the circumference is 10 pi, just multiplying the 2 times the 5. But once again, they said use 3.14 for pi, so I'm going to substitute 3.14 in for pi. And again, you can either do this in your head or you can grab your calculator, and this will be 30.14. Now, this is circumference, it's not area, so it's just going to be centimeters. So if you have any questions on any of those, please let me know.